Hi everybody, welcome to the lesson on measures of relative standing. So in this lesson we're going to look at where one observation is as compared to the other ones in the data set. So we're going to look at three different things. The first thing we're going to look at is z-scores, and then we're going to talk about percentiles, and then outliers. So let's start with z-scores. So a z-score tells you how many standard deviations above or below the mean an observation lies. So if the observation is below the mean, it's going to have a negative z-score. If it's above the mean, it's going to have a positive z-score. And if it's equal to the mean, it's going to be exactly 0. So the formula is x, that's the value that you want to find the z-score of, minus the mean, and then divided by the standard deviation. I didn't write this as x bar and s or as mu and sigma because you can calculate the z-score for either one, for either a sample or the population. So we'll just leave it as x minus the mean divided by the standard deviation. So in this example, men in the U.S. have a mean height of 69.1 inches with a standard deviation of 2.9 inches. And we know that women have a height of 63.7 inches on average with a standard deviation of 2.7 inches. So if we want to compare a 65-inch tall male to a 62-inch tall female, this allows us to do that. And that's actually one benefit of all of the measures of relative standing, is it allows for comparison across data sets where either you have a mean and standard deviation that are just far apart, you've got two different populations, or maybe you've got two data sets that are on completely different scales. In this case, we've just got two different populations. So if we want to find the z-score for the male, that would be 65, because that's the value we want to find the z-score of, minus the mean divided by the standard deviation. That gives us negative 1.4138. And just to make sure you've seen this on the calculator, show you what that comes from. So 65 minus 69.1. Make sure you hit enter there. You don't want to do just the 69.1 divided by 2.9. You want to get your order of operations right. So we're going to do what's on the top, hit enter, and then divide by 2.9. And we get negative 1.438. Right? So now for the female, that female is 62 inches tall. So 62 minus the mean height of women divided by the standard deviation for women. That's going to give us negative 0.6296. So now you can directly compare and see that the male is 1.41 some standard deviations below the mean. The female is 0.63 standard deviations below the mean. Therefore, the male has the lower z-score, so he would be the shorter of the two, relative to others of the same sex. All right. So that's z-scores. So the two things to remember about z-scores are the formula and then the interpretation as the number of standard deviations above or below the mean an observation lies. So continuing on with percentiles. The kth percentile of a data set, so like the 10th percentile or the 20th percentile or whatever it is the value with that percent of the data below it, so strictly below it. So for example, the 25th percentile is one that we look at a lot. The 25th percentile is the value in the data set that's higher than 25% of the data. Okay. I want to point out there's no such thing as the 100th percentile. And that's because if you look at this definition, K% of the data is below this value in the data set. Even if you're the highest data point in the data set, you can't be strictly below 100% of the data. So you can't be below yourself. So there's no such thing as the 100th percentile. So the 3 percentiles that we see the most often are the 25th, which is called the first quartile, or Q1, you'll see that. The 50th percentile, which is the median. It's also called Q2, but we just call that the median. And the 75th percentile, which is the third quartile, or Q3. And then sometimes you'll see them talk about the IQR, which is the interquartile range, which is the between, so between quartile range. So the range between the quartiles, Q3 minus Q1. All right, so here's a data set that we're going to be working with for the rest of this video. These are waiting times at a doctor's office. So in minutes, so one person waited 8.35 minutes, one person waited 3.82 minutes, etc. So if we want to find the percentile of somebody who waited 5.47 minutes, that's this person right here, we first have to put the data in order from least to greatest, and then we just have to calculate what percent of people waited less than 5.47 minutes. Well, 5.47 is right here. We just have 2 out of, there are 12 observations. So 16.67%, and we always round that to the nearest percentile. So that's the 17th percentile. And percentiles are useful for telling you, for allowing you to compare. So if you scored in the 97th percentile on the SAT, but the 94th on the ACT, that tells you that you did a little better on the SAT than on the ACT. So now let's look at box plots. Box plots are a way of looking at the data set. We're going to look more at graphical methods in the next lesson, but for now we're just going to look at this one because this tells us a few important things. The first thing it tells us is, and this is called a box and whisker plot. So if we look at the box, this is the box of the box and whisker plot. It shows us, first of all, what the middle 50% of the data is. It shows us where it is. So this bottom line on the box is the 25th percentile. The top line on the box is the 75th percentile. And there's always a line here in the middle, and that's where the median is. Okay, so on the box plot, that box is always the middle 50% of the data. And so then the rest of it, there's a way of calculating the outliers, and I'm not going to make you do that by hand. It has to do with the quartiles. So it's any data points that are a certain distance away, defined by quartiles. If you want to know more about that, I'll be glad to show you. But anyway, so this is an outlier. So this tells us that we've got an outlier in our data set of 1 minute. First of all, let me show you this 12 here does not mean that this data point is 12. You can see where the data point is by looking over here. So you can see on this scale, the data point is 1. The 12 means in SPSS, it's the 12th observation. So SPSS shows you the observation number because outliers are of particular interest. And so they think that that you might want to go look at that observation. Because, yeah, sometimes that can be interesting. Sometimes it's something you want to investigate because it's maybe an error or, I don't know, a difference in some way that it's different. So that's our outlier. And these are the whiskers here. The whiskers go out as far as the highest and lowest data points that aren't outliers. So if you were to take the outliers out, it's the highest and lowest data point of those that are remaining. All right, so in this box plot, again, we can see that the middle 50% of the data is between, whatever we said that was, 5.55 and 8.36. We can see the median is at 6. We can see we have an outlier at 1. And we can see that the rest of the data goes from 3.82 minutes up to 10.49 minutes. Let me show you how to get this in SPSS. So I've already entered this data here. And this is the same explore function we've been looking at. So analyze, descriptive statistics, explore. And we've got our variable we're going to move over here. But this time, instead of limiting it to statistics, we're going to look at the plots. You might want to see both though, so we'll just put both. And when we click OK, it's going to show us, here is our box plot. Okay? All right, so that is all there is in this lesson. And, please let me know if you have any questions. I'll be happy to talk with you.